Hi guys, welcome to the next lecture. Today I have the plan to work with you guys on the concept of sequences and series. What is a sequence? Let's understand that first. A sequence is pattern. The word sequence, comes from pattern. So it is defined as an ordered collection of things. These things generally are numbers. So we can also say that a sequence is a set of numbers arranged one after another. Pattern and order is very important out here. In fact, sometimes we also refer sequences as progression. In progression or sequences, we generally put the terms like A1, A2, A3, so on and so forth. These are the terms, or you can say that these are elements of any sequence. This subscript that you see here, 1, 2, 3, 4, these are all natural numbers, and they indicate the position that the element is taking. That is why I kept on saying that order is very important. Position is very important. The word sequence actually stands for that. If when we're writing TN or AN or any other letter you can take, generally, TN for term N. So this, as I said, term N. So Tn denotes the nth term of the sequence. So T5 would be the fifth term. T6 would be the sixth term. No matter what the term is, this is just denoting that what we're talking about is the fifth term. What we're talking about is the sixth term. Then what the term is, that's another thing altogether. For example, 3, 5, 7, 9, so on and so forth could be a sequence. If I say 7 I can say is the third term. So I'm going to I can call it A3. Similarly, 9 denotes the fourth term. So I can call it A4 and so on and so forth. When you write down ... that means the sequence is going infinitely. So you have infinite terms here, okay? So it makes me come to the next thing, and that is sequences could be finite or infinite. Now, what is a finite sequence? Finite sequence is a sequence which consists of finite terms. An infinite sequence is a sequence which consists of infinite terms. For example, if I say the sequence is of natural numbers, 1, 2, 3, 4, 5, so on and so forth. This is, the set of natural numbers, everything written in a particular order. So I'm writing it ... because this is an infinite sequence. When I'm writing it ... If I write the numbers from 1 to till say 10, that means I'm just taking 10 natural numbers in this set, or this sequence is finite because you have finite terms here. Let's work on a problem now. Find out the first 3 terms of the sequence Tn, which is equal to minus 1 by n to the power n. How would you get the terms? You will get the terms by substituting. So you got to substitute n. Substitute the value of n. When I say first term, that will be T1. T1 will be minus 1 upon 1. Wherever you have n, just put 1. So you will have minus 1. T2 is equal to minus 1 upon 2 to the power 2. So that's going to give you minus half square, which will be positive 1 by 4. The third term will be T3. N is 3. So that's going to be minus 1 upon 3 to the power 3. Since it's cube, negative will give you negative. So minus 1 upon 27. And that's how you can find out every next term. That's what is sequence all about. It is always depicted in terms of an, where n is a natural number. It could be up till a finite point or moving to infinity. Moving on, let's talk about arithmetic progression. So this is a very special type of progression or sequence. It's a sequence where in which successive terms, they maintain a constant difference. So what does this mean? Let's figure that out. What this essentially means is that you have a common difference in every 2 terms that you take. Consider A, the first term is A. The second term, if I say, is A plus D. So what just happened? We have added D to A and we got our second term, which basically means that this is my term 1, this is my term 2. And when I will look into the difference of term 2 minus term 1, that's going to be D. If I take the third term as A plus 2D, this is my third term. And now if I will look at the difference between T3 and T2, term 3 and term 2, it's going to be D again. If I will take A plus 3D and see the difference between the fourth term, this is your fourth term and third term, again, you have a constant difference, which is D. So you have a constant difference, which is called common difference. So arithmetic progression is all about this. You have a common difference in every two successive terms that you will take. And there are a lot of consequences when this kind of a thing happens. So we can find out the general term. General term, if you are looking at the nth term, if you want to figure out what is the nth term, and since you know that it's an AP, so you know that you're moving A, then A plus D, then so on and so forth, or in other words, A is your first term. So if A is your first term, A is the first term, then clearly what I've done here is, if I want Tn, that is the nth term, what we have to do is, in A, I have to add n minus 1 times D. See what we did here? The second term was A plus D. The third term was A plus 2D. And we saw you get a common difference, right? So what is the general term for an AP? Tn, that is the nth term, will look like A plus n minus 1 times D, where A is the first term and D is the common difference. The moment you use the term common difference, it means every two terms that you will take, the successive terms, the difference will be of D. It's a constant D. Okay. Few points that you must note. Number 1. N is a natural number. Number 2, common difference can be 0, it can be greater than 0, it can be less than 0. Anything can happen. When the common difference is greater than 0, clearly every next term is increasing, right? So it's an increasing arithmetic progression, or it's an increasing sequence. And in fact, the sequence will tend towards plus infinity because it's getting bigger and bigger and bigger and bigger. So it will tend to plus infinity. If D is less than 0, then it's a decreasing arithmetic progression and the sequence will tend to minus infinity. If difference is 0, then that means you are adding 0 to A every time, right? So if you're adding 0 to A every time, that means it's a constant sequence. Nothing is ever changing. It's a constant sequence. It is just the sequence which consists of A. Another important point I want to make here. Suppose T1, T2, so on and so forth till Tm. This is an arithmetic progression that you have. In case you want to figure out the nth term from behind, your end term is Tm. You have m terms, okay? And you want nth term from behind. How do I get that? That would mean that I have to move backwards. Actually, n minus 1 times I have to move backward. And then only I will be able to reach my nth term. And nth term will basically be the m minus n minus 1 term, because you're coming n minus 1 times back. Then only you can reach the nth term from behind. Okay. So please remember that the nth term from the end is m minus n plus 1. That basically means m minus n minus 1 term from the beginning, where m is the total number of terms, and it is given by, as I've written here, it is given by Tm minus, Tm is your last term minus n minus 1 times t again. See, because the common difference is always the same. That is why. Let's work on a question here. If fifth term of an AP is 17 and its seventh term is 15, then find the 22nd term. Let's do it. So we are given that T5 is equal to 17, which basically means that A plus 4 times D is equal to 17 and 7 term is 15. That means A plus 6D is equal to 15. If you will solve for this, what will you get? You will get A cancels. If I subtract, I'll get minus 2D is equal to 2, which implies D is equal to minus. Now you have D. Let's calculate the 22nd term by first I need A. So A will be equal to 17 minus 4 times D. So that's going to be 17 minus 4 into minus 1. That means plus 4. That is 21. So your 22nd term, T22, will be A plus 21D, N minus 1. So N is 22, so 21D. A is 21. D is minus 1. So 21 into minus 1, that means you're talking about 21 minus 21, that's 0. So the 22nd term indeed is 0. One important point in AP, you must always remember that a sequence obtained by multiplication or division of corresponding terms of two APs may not be in AP. For example, if we take the sequence 2, 4, 6, 8, so on and so forth, and we take 1, 2, 3, 4, 5, so on and so forth. Then if you will see the product, it's going to be 2, then 8, then 18, then 32. And you would notice that there is no set pattern in this, okay? So it need not be in AP. Next, let's quickly revise what is a series and how to work it out. A series essentially comes out of a sequence only when you add up all the terms. So if we have a sequence, say T1, T2, so on and so forth, T1, T2, T3, so on and so forth, the series we can get out of it is T1 plus T2 plus T3 plus so on and so forth till say Tn. That means we've added n terms. When we have added n terms, we can call it say Sn. So if you denote Sn, that means what you have done is you have added the first n terms of the given sequence. So Sn denotes that. Again, subscript n, very important. It is telling you how many terms have been added, what terms have been added. For example, if I have, let me talk about notations now. So many a times we use the summation notation, okay, the sigma notation. Now, what do you mean by the sigma notation? Sigma notation, when n goes from 1 to say 9, and we are adding just n. So this would mean when you open it up, sigma notation is basically standing for add. So 1 plus the next term, you add 2, plus the next term, you add 3, so on and so forth, till n equal to 9 you have to add. So till 9 you are adding, okay? So that's what is your S9, you will say. This is what is your S9. Your n is 9 here. Similarly, you can have, say, some other, something else that you are adding up. Say you are adding r to the power a, where r goes from 1 to n. Summation is basically telling you just start giving value to r. If you start giving value to r, that means you're adding 1 to the power a, plus then you're adding 2 to the power a, plus you're adding 3 to the power a, and you are going till n to the power a. This would be called Sn because you're adding n terms and moving till n, okay? So this is what you will say, you will call it n. Now, what are the properties of sigma? For sigma, there are some properties you must remember. Please write down. So you're adding a k times, a plus so on and so forth till a. How many times? K times. So this is nothing but k times a. It's simple sum. Then the next property that you must remember is that summation AI, where I goes from 1 to k, is equal to summation. Second property that you must remember is summation a times I, where I goes from 1 to say k. Now this is different. In this, a is a constant, it can come out, and it's summation I goes from 1 to k. So what's happening? You have a, and then you are adding 1 plus 2 plus 3 till you're adding it till k. A is a constant, okay? Here, A is a constant. Then the third property is adding or subtracting the sums. So summation of AI plus or minus BI, I goes from say 1 to n. This you can break, and this could be written as AI, summation AI, I goes from 1 to n plus summation BI, I goes from 1 to n again. So you can break that plus or minus, okay? But always remember, this does not hold true for products in sum. Now, another one is about the double summations. Double summations like AI, AJ. So I goes from, say, I naught to IN, and J goes from, say, J naught to JN. This could be interchanged as well. This could be summation, double summations, just like double integrals could be interchanged as well. This is not that basic, but yeah, I just wanted to add it as a property of sum you should know. That is why. So I can write I goes from I naught to IN, and I can write J goes from J naught to JN here, okay? Now let me take you back to the arithmetic progression, and let's talk about series of AP. Series of AP. So how you can obtain series of AP? You know the terms in AP, A plus D, so on and so forth. So Sn, that is the sum of first n elements of an AP, will be A plus D plus A plus 2D plus so on and so forth. We're going till Tn. So that would be A plus n minus 1 times D, right? Now I want to actually derive a formula to it. For that, what I'm going to do is I will rewrite this sum, but in the reverse order now. See, 1 plus 2 plus 3 plus 4 is same as 4 plus 3 plus 2 plus 1, right? So I'm going to write A plus n minus 1D. Sn will still remain the same, right? Plus, then the next term will be A plus n minus 2D. So on and so forth. Then it will go up till A plus 2D, A plus D, A plus A, just A. Just A, right? So if you add the two, you will get twice of Sn here because you're adding. What will you fetch in on this side? You will fetch 2n, you will fetch 2a plus n minus 1d. If you will add this and this, you will get 2a plus again n minus 1 times d plus so on and so forth. For every term, that's what you will get. You will get 2a plus n minus 1 times d. So what are you actually fetching? How many times are you fetching this? There are n terms, right? So you're fetching n number of times. You're getting 2a plus n minus 1 times d. So that means Sn actually is n upon 2 into 2a plus n minus 1 times d. What is Sn? Sn is basically the series of AP. That is when you start adding an arithmetic progression, arithmetic series sequence. Then you get this formula to the sum. Sum of n elements would be this. Arithmetic progression is basically a sequence of non-zero numbers. If the ratio of successive terms is constant, which basically means that you'll have a scenario where, say your first term is A, and then the next term is AR, then the next term is AR square. So do you see what's happening? If you will see AR upon A, you're going to get R, which is a constant thing. When you will take AR square upon AR, you will again get R. So that's the common ratio that you have. AR cubed, so on and so forth, depending on whether it's a finite case or an infinite one. If it is, you're looking at n terms, then your nth term will be AR to the power n minus 1. Okay, so that's what is a geometric progression. In this general term, we will be looking at the general term Tn as AR to the power n minus 1. Index depends on what is your starting term. If your starting term, which generally, I'm giving you a general scenario where the starting term is A, then AR, then AR square, and so on and so forth, then your nth term will be AR to the power n minus 1, because you have n terms in total starting from A. Okay. Now, suppose you have a question here that if your 5th, 8th, 11th term of GP are P, Q, and S respectively, then find Q square. So let's work at it. So your 5th term, T5, is equal to P. That implies AR to the power 4 is P. T8 is Q. That implies AR to the power 7 is Q. T11 is R. That implies AR to the power 10 is R. So we have P, Q, R. That could be written like this. Okay. Now, I need square of Q. So Q square is equal to AR7 to the power 7 square, or in other words, it is A square, and R to the power 14. Now, R to the power 14, let's see what it is. It can be written as A square R to the power 4 into R to the power 10, because if the base is same, you can add the powers. So 14 could be broken like this. So that means I have nothing but AR to the power 4 into AR to the power 10. AR to the power 4 is P and AR to the power 10 is R. That means in this scenario, Q square is actually P into R. That's what I've taken, R, right? We've understood the term series, right? So geometric series would be when we are adding the terms of a geometric progression or geometric sequence. So Sn, that means will be A plus AR plus AR square plus till nth term. So AR n minus 1 in the power. That's what will be your general term Sn here. Now we would like to, try to figure out what would be the formula to it. If I multiply R on both the sides, so R Sn will be equal to AR plus AR square plus so on and so forth till ARN. Okay. Now what you can do is you can subtract the two, and I'm going to get Sn common into 1 minus R. And here, if you subtract the like terms, what will happen? Just A is left from above, because you can, let me just change the color. So you will cancel this out. This will cancel, everything will cancel. A would be left plus, in the end, ARN would be left, right? So Sn, that means is, A could be taken common, 1 plus Rn, 1 minus Rn, 1 minus Rn, whole thing upon 1 minus R that comes from that side. Now, this can only happen when R is not equal to 1 for a simple reason. In the denominator, you cannot have 0. Okay, so existence has to be there. So this will happen when R is not equal to 1. This is what your sum of n terms is given. given like, okay? This is what you get as a sum of any particular series. Sum of n terms will be given like this. And then, you can have a case where n goes to infinity. That is, you're adding infinitely. As n goes to infinity, what's going to happen is that r to the power n goes off in case r is mod r is less than 1, strictly less than 1. Then what will happen is Rn would actually become 0, because then it's just a fraction between -1 and 1, and you keep on multiplying by itself again and again. It will become minuscule, just almost 0. So as n tends to infinity, in this scenario, what will happen? You will just be left with a upon 1 minus r. So Sn will just be a upon 1 minus r when mod r is less than 1. When r is anything else, then you will get infinity. So your sum will keep on, diverging. Let's also work with harmonic progression today. So what is a harmonic progression? A sequence is in harmonic progression in case the reciprocals are in arithmetic progression. So for example, if say A1, A2, A3, they are in harmonic progression, that basically means they are in HP. 1 upon A1, 1 upon A2, and 1 upon A3, they are in AP. Then only this is happening, okay? So herein, what you would realize is that a standard harmonic progression is of the form 1 upon A, 1 upon A plus D, 1 upon A plus 2D, so on and so forth till 1 upon A plus n minus 1D, because the reciprocals definitely are in arithmetic progression. We've already done that, right? So this is what you need to know about harmonic progression. And apart from that, certain things that you should note down. Number 1, 0 cannot be a term of a harmonic progression. 0 will not be a term of a harmonic progression, because infinity is 1 upon 0 would mean infinity. That cannot be in arithmetic progression, It's not a finite number that you would see. So that is why 0 cannot be a part of a harmonic progression. Number 2, there is no general formula for finding sum. No general formula. You can always use arithmetic progression to, figure it out. No general formula for sum. Number 3, if ABC are in harmonic progression, that implies 1 upon A, 1 upon B, 1 upon C is in arithmetic progression. Therefore, 2 upon B will be equal to 1 upon A plus 1 upon C, which essentially means that B will be equal to 2AC upon A plus C. What have I done? We know that the common difference, so 1 upon B minus 1 upon A is same as 1 upon C minus 1 upon B, and therefore you will get this term. Okay? And therefore you get that B has to be twice of AC upon A plus C. This is a very common question in entrances. This has been asked as basic and advanced in many entrances for that matter. And many entrances in which you are asked mathematics. It's not just economics that I'm talking about, but entrances wherever you are asked basic maths, you can be asked this question. This is a very, very common question, something that you must probably remember. Let's work on a question. So suppose the third term, sixth term, and last term of an HP is 1 upon 3, 1 upon 5, and 3 upon 203. You have to find n. How many terms are actually there? Okay, so what do you know? That an, I'm going to call it an or tn, whatever you want to call it, you can call that. So that's what is this. So, well, what we will use here is that I know that 1 upon the term, 1 upon the term in HP is in AP. So Tn for an AP, Tn, the nth term is A plus n minus 1D. Now, this means that if we consider AP associated to this harmonic progression, then my third term is 3. Third term of AP is 3. Sixth term of AP is 5. And the nth term of AP is 203 upon 3. Okay. So what can we say? We can say that A plus n minus 1D is equal to 203 upon 3. And we also know that we can also say that A plus 2D is equal to 3 and A plus 4D is equal to 5. And therefore, by solving, A plus 5D is 5. A plus 5D is 5. So first, let's solve these two equations. Very simple. So if you will subtract, you will get AA cancels off. You get minus 3D is equal to 3 minus 5 will give you minus 2. So D is equals to 2 by 3. D is 2 by 3. Clearly, A is 3 minus 4 by 3. That means A is 5 by 3. So you have A, you have D. So which essentially will give you from here that 5 by 3 plus n minus 1 times 2 by 3 is equal to 203 by 3. And hence you know that 5 plus n minus 1 times 2 or 2 times n minus 1 is 203. And that would imply, so you get your answer here, that would imply you have 5 minus 2 plus 2n is equal to 203. Hence, 2n is equal to 203 minus 3, that is 200. So n is equal to 100. So there are 100 terms in this harmonic progression that we just worked with. Okay. So this is what I wanted to discuss in this video. I wanted to discuss your progressions, AP, GP, and HP. It's a basic math